This is an extension for number 8. So the question is, a parabola whose vertex is point V, 2, 3, and focus is 5, 6 has equation ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where greatest common denominator of a, b, c, d, e, and f is 1. Find absolute value of a plus b plus c plus d plus e plus f. So first, this is the diagram of the parabola given of focus of 5, 6, and vertex of 2, 3. So step 1, you find the slope of the equation that passes through v and f. So m equals to 6 minus 3, which is rise over run. So 6 minus 3 over 5 minus 2, which gives us a slope of 1. So second, we have to find the directrix such that V is the midpoint of F and Q, Q as being a point on the directrix. So this is the diagram I drew. So this is the parabola, the original parabola of F, V, and Q, where this entire line is perpendicular to the directrix. So to find Q, which is a point on the directrix, set Q as with coordinate A and B. So that since we know that this is a midpoint of, since we know that V is a midpoint of F and Q, because the distance from Q to V and V to F is the same, then we can use that to solve for the coordinates of Q, and which is 2 equals to 5 plus A over 2. That will give us A equals -1, and 3 equals to 6 plus B over 2, which gives us B equal to 0. So the coordinates of Q is -1, 0. And using that, we can find the equation of the directrix, which is perpendicular, which has a perpendicular slope to the line FQ, and which will give us negative 1 over m, which gives us -1. So using the point slope formula, we can find the equation of the directrix, which is y plus 1 equals to -1 parentheses x plus 0, and we can simplify this equation to x plus y plus 1 equal to 0. So how we proceed from there is, first we have to find the distance between FP and PQ. So the definition of a parabola is that there is the distance between FQ from the focus to any point on the parabola is the same as a point on the directrix to the point. And given that, so the equation that I set up was distance from point F 5, 6 to point P x y, which is a random coordinates on the parabola, is equal to the distance from P x y to the line to the directrix, which was x plus y plus 1 equal to 0. And how, since this is a point to point distance, we can just use the regular formula, which is x1 plus minus x2 squared plus y1 minus y2 squared. That gives us the distance. While to calculate the distance from a point to a line, you use the uses the equation d equals to absolute value of a x naught plus b y naught plus c over radical 1 plus m squared, and to basically we substitute it in this, which will give us this equation. So from point F to P, that will give us radical parentheses x minus 5 squared plus y minus 6 squared, and on the other side, distance from the line from the directrix to the point is basically x plus y, absolute value of x plus y plus 1 over radical 2, which was just 1 plus m squared, which was -1. So then we start to simplify this equation, and how we do, the first step I did was to square to get rid of the radical, and by squaring it you will get x minus 5 squared plus y minus 6 squared equals to x plus y plus 1 squared over 2, and you expand this formula by multiplying 2 on this side and expand all the squares, and that will ultimately give us x squared minus 2xy plus y squared minus 22x minus 26y plus 121 equal to 0. And from there you can tell by, you can find a, b, c, d, e, and f by using the coefficient. A is basically 1, b is negative 2, c is 1, d is negative 2, e is negative 26, and f is 1, 2, 1. And we can basically find the answer to the question, which is find a absolute of a plus b plus c plus d plus e plus f, and that will give us 73.